So, first question. I'm going to picture this at our Nikon far side. Talked a lot there about obviously your use of tools and how they are enhancing your workflow. I suppose a general question that's come to mind for me the last few years is, and I'm obviously not an architect, so your answer's skewed to that side, I appreciate. But do you feel that the current state of digital tools is good enough?
I think good enough. Yes and no. I think there's so many opportunities for take design into their own hands and really do some really innovative things. There's a lot of, I suppose, admin and big company structures that don't potentially allow for kind of what is available at the moment to be used to its fullest. So yeah, there's some really interesting on the structural side as well, in kind of ways to approach structural design and kind of feeding backwards and forwards into form, and whether it's like parameter or something where we could kind of flow very fluidly from kind of form on the architectural side to informing what that structure is doing. But so I suppose I think anything is almost possible at the moment. There's so much that is possible, but equally there's a lot of reluctance, there's a lot of hurdles and I suppose obstacles in the way of achieving that kind of perfect workflows. There's been a few projects where everything's clicked, and it feels like you've got a perfect team of. There was I was doing a stadium with Bjorn Happold. The roof was a gravity stressed tension ring, so. Essentially, all of the weight on the roof is sitting on a tension ring that is form found kind of in equilibrium. But every change that you made on the shape, every change you made in bracing, then it changes the geometries of the roof, and so it's this kind of cyclical process. And so we'd change something on the shape, or that would go into the model. It would come back to us. Then we'd have to update, say, all of our sports lighting and gantry positions because the structure's now half a meter to the left or something. So we created all these computational workflows to link up our models and really, I think, accelerate. We could kind of working in tandem. And unfortunately, Google, the program that we were using there to transfer that, Google purchased and then shortly afterwards.
Just for the audience, sorry, what's Caramba as well?
Caramba is someone in the room that's great, but it's a structural analysis plugin within Grasshopper that kind of allows you to solutions from a bottom up kind of construction. It's kind of visual program.
Okay, yes, okay. Like a low-code solution that plugged in. Okay, fine, grand. No, that's really useful. I've got other questions coming off at the back of that, but I'm going to pass to another member of the panel. I'm going to go to Donya. Same question to you, but from, I suppose, the assessment side. Do the tools meet your needs in the field you're in, or is there an entire? I think a lot of the focus from what I see on social media and from what I see with colleagues tends to be on the design side, tends to be the kind of the generative piece, tends to be the complex project parametric piece. What's your view?
I can't say they're not all good enough, purely because I don't have visibility over all tools that exist and assessing existing. But I can say with confidence, the majority of the machine learning based generative algorithms and generative simulators are towards the conceptualization part, the planning part, the design part. The assessment part is very much on, there's a huge amount of work on using machine learning for damage identification systems. The main problem is not the algorithm per se, it's the data, the quality of the data, the metadata, so how the data has been collected, And the label data. So what does that label data represent? Is it a healthy bridge? Is it a defective bridge? If it's a defective bridge, what kind of defects are we talking about? When is it recorded? So those kind of information, which is critical for any algorithm to actually work properly, just does not exist. So we are in the state of, if you like, data-rich, information insight poor. And because that element does not exist, the algorithms that are shared will be always as good as what you feed it to them. So rubbish in, rubbish out.
Interesting, thank you. Nick, just building on what the other Nicks mentioned a moment ago around kind of blockers in the process, and obviously on the Ramboll side, you're working in the software and technology sort of space now. What problems and blockers do you find in kind of interoperability, whether if that's one of the areas in terms of just generally your engineers getting their jobs done, maybe cultural inhibitions around people's reluctance to use new things? How do you feel?
I think there's always a bit of kind of reluctance in terms of trying to get everyone to adopt new tools. But I actually feel quite optimistic about especially the younger engineers wanting to get, always kind of asking me, how do I get involved in computational design? What tools can I use? And yeah, I think it's quite optimistic about on that front. In terms of the tools that are available, I think we do have some interoperability. It's more you have to develop tools in a step-by-step way. So, for example, on one project, you might develop a certain interoperability, and a different project kind of wants to go a slightly different approach. Then you end up kind of, unless we standardize the approach, you always kind of end up slightly reinventing the wheel, and the scripts that you've used on one project not be applied to the other. I guess it's more of a standardization problem, I guess. And the tools are there. It's just that we need to think more long term about how to deploy them across all projects. I think that's the main thing in terms of like blocker. I think generally people do want to use tools if they worked well. But I guess it's the question. It's a case of like, are they good enough to the point where are they good enough to the point where they can be used on every project, kind of with very little setup time? And I think that's the. So I'm not really blaming people. I'm kind of blaming the fact that these computational design tools take investments. They take someone just getting their head around them, and there's not always that on a project really. So. Just
to finish that point there, do you think that's a problem related perhaps to more like IT delivery rather than necessarily, because I think there's a bit of a dichotomy. I mean, I see this firsthand between obviously traditionally engineering firms of any kind would have basically got their ITs to procure software for them on their behalf, installed them, rolled them out. And I feel like a lot of this stuff, because it's kind of a mishmash kind of collection of software we take from various places, we are sort of in charge of delivering it ourselves as well. And that potentially, I think, for certain parts of the businesses is a deterrent, because it's like, well, we don't really have enough IT knowledge, or we're not really willing to tinker enough or haven't got the time, I suppose, to tinker enough to work these things out. Would you agree with that?
Yeah, I mean, I think it's often a case of there's not enough time on a project, I guess. I think engineers generally are inquisitive, and they will try to get to the bottom of why something isn't working or whether something is good enough or not. It's more a case of if you've got a project deadline, you kind of probably want to use a script that you want to use a tool that you've used somewhere else or that you trust someone else has used. And someone in a different part of the business may have different experiences, and they're going to want to do something different. Then all of a sudden we've got lots of different workflows that kind of aren't standardized, that can't be developed as effectively because multiple work streams going on at the same time. So time is money.
No, that's very true.